Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is the continuation of section 7.2 about intersection and union of events. Today we will talk about, in this lecture, we will talk about mutually exclusive events. So, what is the meaning of mutually exclusive? Well, E and F are mutually exclusive if their intersection is phi. So, there is no intersection between E and F. Look here to this Venn diagram. This is E, this is F, nothing between them. So we usually have E like this and F like this, and this region is the intersection. But in this case, there is no intersection between E and F. So we call them mutually exclusive. What would be the probability of E intersection F? Well, E intersection F is phi, so the probability of E intersection F would be 0. So the probability of E union F, E or F, could be written as probability of E plus probability of F only because we will subtract 0. So that's all about mutually exclusive. Mutually exclusive means there is no intersection. Intersection is phi. Find the probability of obtaining a 6 or 4 in one roll of a die. When we roll a die and notice the number of dots on the top, how many dots we can see? Well, either 1 up to 6. So this is the sample space. A single outcome could be 3, could be 4. Now, can we see 6 and 4 together? No, it's either 6 or 4. So what is the probability of obtaining 6 or 4? It would be probability of 6 plus probability of 4 because 6 and 4 are mutually exclusive. Probability of each number is 1 over 6. So the probability would be 2 over 6 or 1 over 3. A firm is considering 3 possible locations for a new factory. The probability that site A will be selected is 1 over 3. So we can say that this is probability of A. The probability of B is 1 over 5. Only one location will be chosen. So he mentioned 2 locations. He did not mention the third one. What is the probability that site A or site B will be chosen? Well, we need to choose a location for the firm. And it is one of these 3 positions or locations. Can we choose A and B together? No, either A or B, but not both. So these 2 are mutually exclusive. So probability of A or B is probability of A union B, and it's probability of A plus probability of B because they are mutually exclusive, and it is 1 over, uh, this is A, probability of A is 1 over 3 plus probability of B is 1 over 5. So the answer would be 8 over 15. Now, what's the probability that neither A nor B? Neither nor means 1 minus probability of the union. This is always neither nor, okay? So 1 minus 8 over 15, and the answer is 7 over 15. So in general, if this is a sample space and this is A and this is B, so neither nor means everything here outside A union B, okay, outside A union B. So this is neither nor. you can say that neither nor is the complement of the union. Okay, so let me write it. It is B of A union B complement. Okay, so it's the complement of the union. Okay, the formula for the probability of the union of mutually exclusive events, which is the sum of the two, can be extended beyond two events. So if we have n mutually events, the probability of their union, mutually exclusive events, this would be the probability of their union, just their sum. All right. Find the probability of rolling two distinct dice. You notice in section 7.1 we mentioned the sample space for this experiment when we roll two distinct dice, and we have seen that number of elements in the sample space is 36 in this case. A sum greater than 9. Well, I need to, let me call it event E, and I need to have all the outcomes with sum greater than 9. So I have, let me start from 6. I have 6, 6, 6, 5, 5, 6, 5, 5. Okay. There is also 6, 4, 4, 6. 6, 3 is not greater than. Do we have anything else, any outcome that could be greater than 9? So 6, 6, 6, okay, 6, 4 is not, 5, 4 is not. That's it. So 2, 4, 6. So probability of E is 6, a sum greater than 9. So probability of E would be 6 over 36. I can answer the question like this. Okay. The probability would be the sum of all probabilities, if you like, of the events. Okay, B, 6 on the first die and a sum is greater than 9. And so we need the sum to be greater than 9. And these are all the possible cases, 9 possibility. So what would be, we need to choose 6 on the first die. Okay, we need to choose 6 on the first die. So 6, 6 is there, 6, 5 is there, and 6, 4 is there. So what is the characteristic here? Every outcome has 6 on the first die and the sum is greater than 9. So probability of F is 3 over 36. Part C, 6 on the first die or a sum greater than 9. Well, let me call this G. I have some greater than 9. These are the 6, so let me write them. And now I will write all the outcomes with 6 on the first die because he needs OR. I have 6, 6, 6, 5, 6, 4, so I still have 6, 1, and 6, 2, and 6, 3. So here, each outcome is either the sum greater than 9 or the first die is 6 or both. How many? 9. So probability of G is 9 over 36. An ordinary die is toast. One die. What is the sample space? From 1 to 6. What is the probability of getting a number divisible by 3? So divisible by 3, what do we have? 3 and 6. Uh, I can call it E, I can call it D, it is no problem. Odd number, let me call it O. The odd numbers are 1, 3, and 6. So what do we need? The probability of D union O. So it is the probability of D, this is one way to find the answer, plus the probability of O minus the probability of the intersection. Is there an intersection? Yeah, 3, 6, 3, 6. So 2 over 6. So the answer is 3 over 6. So here, this is not, these two events are not mutually exclusive. Are not mutually exclusive. Divisible by 3 and odd. Oh, there is 5. 5 and 7, sorry. 6 is not odd. 1, 3, 5, 7. So this is 4. And the only intersection, they intersect at 3 only. So this is 1. So 4 plus 2 minus 1 is 5 over 6. There is no 7. There is no 7. Okay, so this is 3. So the answer is 4 over 6. Okay, I need to concentrate more. A card is drawn at random. A card is drawn at random from a deck of 52 playing cards. Find the probability that it's a club. How many clubs are there? 13. Or a king. How many kings are there? 4. So probability of club or king would be probability of clubs plus probability of kings minus probability of clubs intersection kings. How many clubs? 13 over 52. How many kings? 4 over 52. Do you have a king of club? Yeah. So 1 over 52. So the answer 16 over 52. Suppose a die is biased. Biased means it's not fair, unfair. So that each odd numbered face has probability 1 over 4. You know, when we toss a single die or roll a single die, the numbers are from 1 to 6. So here probability of 1 equals probability of 3 equals probability of 5. All the odd numbers, their probability is 1 over 4. While each even face has probability of 1 over 12. So probability of 2 equals probability of 4 equals probability of 6 equals 1 over 12. Now, this probability distribution should satisfy the condition that the sum of all probabilities is 1. The probability of S is 1, as you know. So this is 3 over 4, and this is 3 over 12, which is 1 over 4. Yeah, the sum is 1. Okay. Find the probability of getting a number greater than 3. So this is the event. Greater than 3, I have 4, 5, and 6. What is the probability of E? Well, this is not an equiprobable event, so you cannot say the answer 3 over 6. But how to find probability of E? It would be probability of 4 which is 1 over 12, plus probability of 5, which is 1 over 4, plus probability of 6, which is 1 over 12. And the answer, you find the answer. This is 3 over 12, so it's 5 over 12. The answer is 5 over 12. A card is drawn from a deck of 52 playing cards. What is the probability that it is an ace, a king, or a jack? So a ace, union, king, union, jack. You know, there is no intersection between ace, king, and jack. Either the card, if it is an ace, it cannot be king or it cannot be jack. So here the probability would be probability of A because these three are mutually exclusive, plus probability of K, plus probability of J. What is probability of A? Ace, how many? We have 4. King, we also have 4. Jack, we also have 4. So the answer is 12 over 52. A bag contains 4 white, 7 black, 6 green, 3 colors. What is the probability that a ball drawn at random from the bag is white or green? Can the ball be white and green together? No. So it's probability of white or green, and it would be probability of white plus probability of green, mutually exclusive. How many white balls? 4. What is the total number of balls? 11 plus 6, 17. How many green balls? 6 over 17. So the answer is 10 over 17. This is the probability of white and green. A cube has 3 faces painted white. All right. 2 faces painted red, 1 face painted blue. How many faces are there for the cube? 6. Okay. So what is the probability that a roll will result in a red or blue? You know, it cannot be red and blue together. So these are mutually exclusive. So the probability of the union is probability of red plus probability of blue. How many red faces are there? 2. And the total number is 6. How many blue, sorry? 1 blue. So the answer is 3 over 6. A ball is drawn from a bag containing 13 red, numbered from 1 to 13. 5 white, numbered from 14 to 18. Not red. What is the probability that the ball is not red? How many red? 13. How many not red? 5. So it's 5 over 18, the total number of balls. White and odd numbered. Okay. The white balls are from 14 to 18. Okay. So what about the odd numbers of these white? What are the odd numbers from 14 to 18? Well, 15, 17, 15 and 17 only. So white and odd, there are 2 balls, white and odd. So 2 over 18 is the probability. White or odd? Okay. Now all the odd numbers are 1, 3, 5, 7, 9, 11, 13, 15, 17, 4, 6, 7, 8. 8 numbers odd or white. So I'll use the formula. I have 8 over 18. This is probability of odd plus probability of white. I have 5 white minus probability of odd and white. How many odd and white? 2. So the probability would be 13 minus 2, 11 over 18. Neither white nor odd. It is 1 minus 11 over 18. We said neither nor means the complement of white or odd. So the answer is 7 over 18. That's the end of this section. I hope, I think it's easy. Thank you very much and have a nice time.